Title of the first section is Order from least to greatest. Order from least to greatest. In other words, we're going to order from smallest to biggest. First problem, first sets of numbers, is 2, 6, 13, 5, and 4. We'll take these 5 numbers and order from least to greatest. The smallest of these numbers would be 2. The next smallest number would be 4. After 4, the next smallest number would be 5. Next smallest number after 5 would be 6. And the biggest number, or greatest number, would be 13. So ordering from least to greatest, we have 2, 4, 5, 6, and 13. Second question. Sets of numbers are 5, -5, 3, -2, and 0. Again, we'll order from least to greatest. This time we have negative numbers, -5 and -2. Negative numbers are always smaller than any other number. If we have -5 and -2, the smallest of those, which is farthest away from 0, would be -5. And the next smallest would be -2. 0 comes before any positive number. And last two numbers we have are 5 and 3. 3 would be smaller, and 5 would be our greatest number. So the order of the numbers, -5, -2, 0, 3, and 5. Next question and last question for this section. We have the absolute value of -3. Absolute value is 2 vertical lines around the number. Next number is absolute value of 2, 0, 1, and 4. To find the absolute value of a number, whatever the number is, you make that number positive. So absolute value of -3, change it to positive, and that would be +3. Absolute value of +2, if the number is already positive, it stays positive. Just take the absolute value signs off, and the other 3 numbers I'll rewrite 0, 1, and 4. And now we can order these numbers from least to greatest. Smallest number would be 0, and then 1, and then 2, and then 3, and the greatest number would be 4. So ordering from least to greatest would be 0, 1, 2, 3, and 4. If you wanted to, you could leave the absolute value signs on here, or you can take them off. Title of next section is Compare. Using greater than, less than, or equal. As part of the definitions for this section, greater than. Greater than symbol looks like this. And the second definition, less than. The less than inequality is the opposite and opens the opposite way. First problem for the section, we have 5 and positive 3. In between these two numbers, we want to either put greater than, less than, or equal to. Since we have 5 and then 3, 5 is bigger than 3, or also 5 is greater than 3. So the greater than symbol would be 5 is greater than 3. Second question, we'll have absolute value of negative 7. And on the right hand side, we'll have positive 7. And again, like before in the previous section, absolute value of a negative number, or negative 7, we can take off the absolute value signs and change it to a positive number. So we'll have positive 7 on the left hand side, and the right hand side would stay the same. So now we have 7 on one side, 7 on the other side. It's not greater than or less than. In this case, 7 is equal to 7. And last question for this section. We have negative 4 and negative 2. Negative 4 and negative 2, if you think of a number line, negative 4 is on the left-hand side of negative 2, which means negative 4 would be the smaller number, and negative 2 would be the bigger number. So in this case, negative 4 would be less than negative 2. If it helps, you can draw a number line, which goes negative 4, negative 3, negative 2. Negative 4 being on the left-hand side means that the negative 4 is smaller and negative 2 is bigger. So negative 4 would be less than negative 2. Looking at the graph, we'll answer the following question. How many hours of homework was assigned week 1? Looking at the graph on the vertical axis, also known as the y-axis, we have the hours 1, 2, 3, 4, and 5. And along the horizontal axis, which we call the x-axis, we have the weeks 1, 2, 3, 4, and 5. If we want to look for the hours on week 1, we'll go to week 1 on the x-axis. We'll go up to the point for week 1 and see how many hours it's associated with, which should be 1 hour. So how many hours of homework was assigned during week 1? The answer would be 1 hour. Second question and last question for the section. What was the change of hours from week 1 to week 2? So the change is how much it changed from one week to the other week. So we have to look at week 1 and figure out how much it changed to week 2. Week 1, we already know, started at 1 hour. If we look at week 2, go up to the point, matches up with 3 hours. So we had 3 hours of homework in week 2, and the change will be the difference from going from 1 to 3. So the change was 2 hours, or an increase of 2 hours. Title of the first section today is titled Adding Integers. Integers are any whole numbers, positive or negatives, but do not include decimals or fractions. For the problems for this first section, I'll use two different colors of pen. If you have two colors, you can use two colors, or you can just use one color. The first part will have -3, but instead of -3, what I'll do is I'll draw 3 number tiles, each with a -1 on the inside. And I'm using red to represent the negative numbers. So we have 3 -1 tiles, which will represent the number -3. To that we're going to add -2, but again, instead of -2, I'll put 2 -1 tiles. And then we'll put equals after. So this question, using algebra tiles, or these square blocks, we have 3 -1s. We're adding to that 2 -1s. Since all the tiles are exactly the same, we can add them all up, and there's 5 of them. 5 -1s would represent the number -5 for our answer. So anytime we're adding negative numbers, we can just add the negative numbers and keep the negative on there. For the second question, we'll have +4, which I'll represent by 4 number 1 blocks. And to that we'll add -2, but again I'll use the red pen to represent 2 -1 tiles. So this problem would be 4 plus a -2, and we'll find out the answer. This time the tiles are different. We have a +1 and a -1. When we're adding tiles like this, or positive and negative numbers, you can think of 0 pairs or canceling. For example, +1 and -1 would create 0. So we can cancel one +1 and one -1 out. Same thing with another +1 and another -1. These are called 0 pairs. 1 plus the -1 would cancel and make 0. So we can cancel those out. And we're left with 2 +1 tiles, which would be +2. So the original question, 4 plus a -2, would be +2. Title of the next section of notes is More. Adding integers. And again, the definition of an integer is any positive or negative number, but does not include decimals or fractions. 2 definitions for this section. The first rule that we'll follow is same signs. You add. And the second one, different signs. You subtract. And keep the sign of the bigger number. So instead of using algebra tiles like we did in that last section, we can follow these 2 rules to add integers. If they're the same sign, they're both positive or both negative, we'll add those together. And if they're different signs, meaning one's positive and one's negative, we'll subtract the 2 numbers. That's kind of like canceling out the 0 pairs. And we'll look at the bigger number, but we'll ignore the sign, positive or negative, in front of it. Just look at the number itself, and the bigger number will tell you if it's positive or negative. First problem we'll look at, in parentheses, -6 plus a -3. So if we look at this question, we have a -6 and a -3. Both numbers are negative, so we have these same signs. So we'll add the numbers 6 plus 3, which will be 9. And if the numbers are both negative, then we'll keep the number negative. So the answer would be negative 9. Second question, in parentheses, negative 3 plus, in parentheses, negative 8. Again, looking at the two numbers, we have negative 3 and negative 8. Both numbers are negative, so again we have the same sign. If you have two negative numbers, you can add those together, and since they're both negative, the 11 would stay negative, and our answer would be negative 11. Third question, 9 plus, in parentheses, a negative 2. This time we have a positive 9 and a negative 2. So we have different signs, a positive number and a negative number. When we have different signs, we'll subtract the numbers. 9 minus 2 would be 7. And we'll keep the sign of the bigger number. If we have the number 9 and the number 2, 9 is bigger, 9 is positive, means our answer is positive. So we'll have positive 7. And last question for the section, negative 7 plus, in parentheses, positive 5. Again, look at the two numbers. We have a negative number and a positive number. Different signs. Whenever we have different signs, you'll subtract. You can ignore the negative when you subtract. We'll have 7, and we'll take away 5. 7 minus 5 would be 2. And again, to determine if it's positive or negative 2, look back at your numbers. Whichever number is bigger, ignoring the negative. 7 is bigger than 5. The sign in front of the bigger number tells you that's negative 2. Title of the first section today is Subtracting Integers. And again, integers are any positive or negative numbers, but do not include decimals or fractions. We'll start today again by doing number tiles with the red and black colors. First number we'll take is negative 3. And again, negative 3 will represent by 3 negative 1 tiles. And from that we'll subtract positive 2 or 2 positive 1 tiles. So we have negative 3 minus positive 2. When subtracting integers, the subtract goes to each of these. The minus goes to the first number 1 and also to the second number 1. So what happens is if we're minusing 1, this positive 1 will change into a negative 1. Same thing with the second tile. If we're subtracting 1, that 1 will change to a negative 1, and these positive ones will cancel out because we switched them. So now we're left with 3 negative 1 tiles, and we have 2 negative 1 tiles. If they're both the same, we can add those, there's 5 negative 1s altogether, which would be negative 5. Second question, and last question for this section. We'll start with positive 2, which would be 2 number 1 tiles. And from that we'll subtract a negative 1 tile. Again, when we're subtracting, this minus sign goes to the tile. When you subtract a negative number, the minus minus will change to a positive, so we'll be left with a positive 1 tile. And this will equal, we have 2 and 1 extra 1 tile, which would be positive 3. Title of the last section of notes today is More. Subtracting integers. Couple definitions for this section, which are similar to the ones we did yesterday. Same signs. You add and keep the sign. Second definition, different signs. You subtract and keep the sign. Of the larger number. And the last definition that we'll need to know for this section is minus minus is plus plus. That is, when we have two subtractions next to each other, minus minus, we'll change that to two additions, plus plus. The first two rules are the same as when we add the integers from the previous section. If they have the same signs, we'll add. If they have different signs, we'll subtract. First problem we'll look at, in parentheses, is negative 5 minus 3. In this question, the 5 is considered negative, and since the 3 has a minus sign in front of that, we'll consider the 3 to be a negative number. So we have a negative 5 and a negative 3. Both signs are the same. So again, if we have these same signs, we'll add and keep the sign. 5 plus 3 would be 8. And the same signs, we'll keep the sign. So it'll be negative 8. Negative 5 minus 3 is negative 8. Second question, negative 7 minus 4. Again, looking at these numbers, the 7 we'll think is negative, the 4 we'll think of as negative. So both numbers are negative in front. So again, if we have the same sign, we'll add and keep the sign. 7 plus 4 would be 11, and we'll keep the negative on there. So negative 7 minus 4 would be negative 11. Third question we'll look at, 7 minus, and then parentheses, negative 2. In this case, we have two minus signs with no number between them. There is a parentheses, which is okay, but if you don't have a number between the minus signs, that's where we'll use a definition minus minus is plus plus. If you have two minuses side by side, we can change each of those to addition. And now the problem would be 7 plus 2. 7 plus 2 would be 9. Next question for the section. We have 4 minus 8. This question we have a positive 4 and the 8 we'll think of as a negative 8. So a positive 4 and a negative 8 are different signs. Back at the definitions, when we have different signs, we'll subtract the numbers and keep the sign of the larger number. When you subtract, just subtract the bigger number minus the smaller number. So 8 minus 4 would be 4. And to determine if it's positive or negative, you look at the bigger number without the positive or negative signs. 8's bigger, and the sign in front of that negative tells us our answer is negative. Next question we'll look at. Negative 15 minus, in parentheses, negative 4. Again, on this question, we have two minuses with no number between them. When we have minus minus, we can change that to plus plus. So the problem will change to negative 15 plus 4. We have a negative 15 and a positive 4. Different signs. Anytime we have different signs, we'll subtract. 15 minus 4 would be 11. Now always remember, look at your bigger number. In this case, 15 is the bigger number. The sign in front, negative, goes with the answer. Negative 11. And last question for the section. 6 minus 12. In this case, we have a positive 6 and a negative 12. Different signs again, so we'll subtract. You can always subtract the bigger number from the smaller number. 12 minus 6 would be 6. And you look at the bigger number between 6 and 12. 12 is bigger. Since 12 is negative, we'll keep the negative sign, negative 6. Title of the first section today is multiplying integers. Again, integers are any positive or negative whole numbers, but they do not include decimals or fractions. Two definitions for this section. First definition, same signs. Answer is positive. And the second definition, different signs. Answer is negative. What this means is when you multiply two integers or any two numbers, if they have the same sign meaning they're both positive or they're both negative, when you multiply the answer will be positive. and vice versa if you have different signs, meaning one number is positive